Hi everyone, my name is Miranda Tignor and this is my presentation on cursor and repeated SQL for HAP 671 healthcare databases. To begin the presentation, we'll go over some background about cursors and do-while loops, and then we'll move into the LM8 assignments to go over the individual questions. So first, what is a cursor? In SQL, data is usually processed in a set. However, a cursor can be used to analyze data row by row. Since results are processed row by row, analyzing data with a cursor can be slow and time-consuming. There are 4 steps in a cursor. First, you declare your cursor by specifying the name. Then open the cursor. This allows you to process and run the SQL statement. The next step is fetch, which analyzes the data row by row in the table. In this section, you can specify which actions or calculations you want to perform on your data. And then last, you close the cursor. A do-while command is a type of loop that executes a block of code at least once and then repeats it as long as a condition is true. In this slide, we go over the syntax of a do-while command. So first, we declare the index as an integer. Then set the initial index value. In this example, the index is set at 1. You then create a while loop to tell your computer when to stop. This is represented by the max value in the code below. Begin statement will start the calculation, and then after your begin statement, you can enter your calculations. And then after the initial calculation, the index will be raised to whatever it is set at. In this example, the index is +1. The loop will continue until the maximum value is reached. Then the end command marks the end of the calculations. Now to move into the LM8 individual assignment, there is 2 parts to this assignment. But first, the background. So refer to patient 457631 that was analyzed in last module's individual assignment. This patient has been hospitalized at age 58 with the 5 diagnoses listed below. For part 1 of this question, we will use the data file to calculate how many patients show in the data with 2, 3, 4, and 5 combinations of these diagnoses. And then for part 2, we'll use a do-while command to go through the various combinations of these diagnoses and calculate the odds of mortality for each of these combinations. For part 1, this code creates a new column called diagnoses, which assigns a value of 1 or 0, depending on whether the ICD-9 code matches one of the 5 specified codes. The where statement in this code filters the rows to only include rows where the ICD-9 code is one of the 5 ICD-9 codes that we're interested in. Then the group by statement groups the rows by ID and ICD-9. This is done so we can calculate the number of ICD-9 codes that each patient has. For example, in row 1, the patient 152068 has the diagnosis of I401.9, which is displayed by the 1 in the second spot of 01000. In the next section of the code for part 1, we declare the index as an integer and then set the index to 1. Then we create a while loop with the max value set at 5. The output of this code will create ICD-9 combinations related to the 5 diagnoses specified in the previous slide for each distinct patient ID. Next, we want to calculate how many patients have 2, 3, 4, or 5 diagnosis codes in total. To do this, we use a where statement to filter out the rows where the combinations column has a value of 1, 10, 100, 1000, or 10,000, which means the patient has only 1 diagnosis code. Then the sum function gives us the total number of distinct patients who have more than 1 diagnosis code. For example, row 1 states that 952 patients have 2 of these diagnoses, while row 2 says that 5,560 patients have 3 of these diagnoses. Part 2, we want to calculate the odds of mortality using a do-while loop. However, before we can calculate that, we need the likelihood ratio for each diagnosis combination. For the first block of code, we create a temporary table, part2_1, from the final clean table that selects ID and age at death if applicable. Then we want to count how many of these patients are dead or alive overall. If a null value is present in age at death, we count the patient as alive. If an age is listed, we count the patient as dead. Once we have the overall total of dead and alive for our data, we calculate how many patients are dead or alive based on each ICD-9 code as shown in the output. In the next screenshot, the likelihood ratio is calculated. The final output of this code is a table that shows the combinations of diagnosis codes and their corresponding likelihood ratios for a subset of patients who have one of the 5 diagnosis codes specified. Lastly, to calculate the odds of mortality, we create a do-while loop with an index set at 1 and use the likelihood ratio to calculate the odds of mortality based on every combination of ICD-9 codes from the 5 we are interested in. The final output shows the possible combinations of diagnoses along with the odds of mortality. A higher odds means a stronger association between the combination and death. Thank you for watching my presentation. For my references, I use Dr. Alemi's PowerPoint slides from the LM8 module about cursors. Thank you.